Okay, so we're splitting lesson 7-7 into 2 days. The first day we're going to work on writing quadratic equations, and then the second day we'll work on solving word problems about finding maximums and minimums. So the way these problems are going to go is you are going to be given the answers. You're going to be given the roots of the quadratic equation. The roots or the solutions or the zeros, whatever you want to call them, those are all synonyms. And then you need to come up with the original equation. So this definition up the top is what we're going to be using, and that is all quadratics are of the form x squared minus the sum of the roots times x, and then the product of the roots for the constant term. You know this. I mean, if we were to try to quickly prove this by example, just think about the fact that, okay, well, let's solve this. So x times x factors into 1, so plus 1 plus 1. So we'll get x equals -1 and x equals -1. So those are the roots. So going backwards then, the sum of those two numbers is -2. And the product of those two numbers, when I say two numbers, I mean the -1 and the -1. So then the product of -1 and -1 is 1. So now if I use this definition up at the front, it's x squared minus, there's a minus sign there, the sum, which we said was -2 times x plus the product of the roots equals 0. Well, if I simplify this, I just get right back to where I started. So what I just did there was just prove to you that that's true, and now we'll use that equation to answer all of our other questions. So here's an example of what it'll look like on the homework. It'll say, find a quadratic equation with the given roots. Again, if I use the word zeros or if I use the word solutions, I mean the same thing. Those are all synonyms. So, very plain and simple here. We need to find both the sum and the product of these numbers. So when I find the sum, I'm just going to do 4 plus -7, so that's -3. And then I'm going to do 4 times -7 is -28. Now using my equation, it's always x squared minus the sum. So minus -3 times x plus the product, -28 equals 0. So if we just clean that up a little bit, we get x squared plus 3x minus 28 equals 0. You don't have to, but you could double check that this is correct by factoring and solving this. So if I just factor this real quick, x times x, we know 7 and 4 will multiply to 28, and we want to get a +3. So you'll get x equals 4 and x equals -7. So that checks out. We know we found the correct quadratic equation. All right, next one here. Find a quadratic equation with the given roots. Now we have imaginary roots, but we're going to do the same thing. First, we'll find the sum. So we have two imaginaries there. We have 3 plus I, and we're going to sum that with 3 minus I. So when I add imaginaries, remember real part with real part, so 6. Imaginary with imaginary, so plus I minus I just reduces to 0. So the sum is just 6. Now for the product, I'm going to do 3 plus I times 3 minus I. So we got to distribute here. 3 times 3 is 9. We get +3i and -3i. I'll write it out, but we know those are going to reduce to 0. And then I times -i is -i squared. So like I said, these reduce to 0. And don't forget, I squared is -1. So what we really have is 9 plus 1, or 10. And now we just put that together. X squared minus the sum times x plus the product equals 0. Okay, another one of those. Again, we're writing this as plus or minus, but you can just think of them separately. We have the root 2 plus I over 3, and then we also have the root 2 minus I over 3. So first we'll find the sum of those. So if I take 2 plus I over 3 and add it up with 2 minus I over 3, these are fractions with common denominators. So we can just add across the numerators. So it'll be 2 plus I plus 2 minus I. So in the numerator, 2 plus 2 is 4, and I minus I reduces to 0. So we get 4/3. Now the product, 2 plus I over 3 times 2 minus I over 3. We'll just multiply numerator with numerator and denominator with denominator. So you'll see in the numerator you are going to have to do some distribution, but in the denominator just 3 times 3 is 9. So in the numerator we got 2 times 2 is 4, positive 2i and negative 2i reduce to 0, and so then just negative I squared. Don't forget I squared is negative 1, so what we really have is 4 minus negative 1 over 9, which is 4 plus 1, so 5/9. Putting that together, we get x squared minus 4/3 x plus 5/9 equals 0. Okay, switching gears a little bit, we got one more example. It says find a quadratic function in general form, like you see, such that the maximum value of the graph is 8 and the x-intercepts are 3 and 7. So I'm going to kind of sketch a picture to get an idea of what's happening here. It's not going to be perfect, but so I have my x-intercepts 3 and what was the other one? 7. And then my vertex is up at 8. So more or less I have some sort of parabola that looks like this. It opens down, something like that. We got our axis of symmetry. Okay. So what I'm trying to do is write an equation. So we know f of x equals ax squared plus bx plus c in general form, but what's going to be easier to do here is to just start in vertex form. And then we can move this to general form at the very end. So there's vertex form. We can plug in our vertex if we know h and k. Well, we know that the maximum value is 8. The maximum is going to be the vertex. But we don't know the x-coordinate of that. So right now we only have our k. We have that our k is 8. But we can easily find what this x-coordinate is because the vertex is always going to be midway between the x-intercepts. So we can find this by just taking an average of those x-intercepts. So we have 3 and 7, so if I just do 3 plus 7 over 2, average them out, I get 5. So that tells me what that x-coordinate is. So now in my vertex form, I can plug in my h is 5 and my k is 8. Now I still need one more thing. I need my a value. And the way that we can get an a value is by just choosing another point on the graph. So I might choose one of the x-intercepts, like for example we know this one is 3 and 0. So I'm going to plug that in for my x and y. So my y is 0 and my x is 3 at that point. And that's going to allow me to solve for my a. So let's see, I'll get negative 2 squared in parentheses, so that's 4a plus 8 equals 0. So then if I subtract 8 and divide by the 4, I'll just get negative 2 for my a. So far so good. I have a complete function in vertex form. Oops, I meant to plug in. So f of x, we know that a is negative 2, x minus 5 squared plus 8. But this question did say find an equation in this general form. So we are going to have to go ahead and do the distribution here, distribute the 2 through, so that we can get it in general form. I need a little more room, so I'm going to slide this up. Okay, so now to get it back in general form, I'm going to go ahead and first distribute x minus 5 times x minus 5. So that's going to be negative 2 times x squared minus 10x plus 25. So then if I distribute this negative 2 through to everything, I'll get negative 2x squared plus 20x minus 50. And then I still have that plus 8 out there. So all together then, we have f of x equals negative 2x squared plus 20x, and then if I do the 50, negative 50 plus 8, I get negative 42. And there it is, my final answer. Let's back it up a little so you can read it all. Alrighty, so that's lesson 7.7, day 1. So day 2 will be word problems when we get there. And we're just about done with the chapter.